This is section 7.3, the law of cosines. And the law of sines applies in cases where the known angle and opposite side form a complete ratio, such as side A divided by the sine of angle A. Now, the law of cosines may be used for cases in which a complete ratio is not given. So let's take a look. Two sides and the angle between them are known, and three sides are known. So let's talk about the law of cosines. We have triangle ABC with sides ABC, and then the opposite vertices ABC, which is where the angles are. The law of cosines looks like this. A squared equals B squared plus C squared minus 2BC. So that's here, BC. And then the cosine of angle A, which is this A here, this side squared. So there's a very nice pattern here. Let's do this for the next option. If we are looking for B, we would then have to have side A, side C, there's the sides, and then also the cosine of B. So all of these are your side angle side. Okay? We can go ahead and do the last one. We're looking for side C, and we have angle C. We also have side A and side B. Now we do have an alternate form. And what do you notice? This law of cosines, this has the side angle side. Okay? Here we have side, side, side. So we're looking for the cosine of A, B, or C. And here we have sides A, B, and C. So here we're looking for angles and we have none. So let's try to solve a triangle using the law of cosines. And here is what we have. We'll be given side angle side, and we have an oblique triangle. We will first find the length of the side opposite the known angle by using the law of cosines. Then we'll go back and use the law of sines to find the measure of the angle opposite the shorter of the two given sides. This angle will always be acute. Okay? It will not involve an ambiguous case. You can also use the alternate form of the law of cosines. Then we'll find the measure of the third angle, which we're very good at because the sum of the measures must be 180. So let's give number 1 a try. Solve the triangle. Round measures to 1 decimal place if necessary. As you can see, we are given side, angle, side. Okay? So now that we have side, angle, side, let's go ahead and look for side A. So side A squared, and this is our law of cosines, is equal to side B squared plus side C squared. And then as you can see, we're going to subtract. Take a look up here. We're going to subtract 2 times both of those sides multiplied by the cosine of A. So minus 2BC cosine of A. So let's fill that in. A squared, A is what we're looking for, is equal to 19 squared plus 22 squared minus 2 times 19 times 22 multiplied by the cosine of 38 degrees. So these are side angle side. Now, if you'll work this out using your calculator, make sure you're in degree mode. Okay? And you will come up with 186.223. So if we take the square root of that, we get approximately 13.6464. So A is approximately 13.6. Okay, let's now use the law of sines to find angle B. Or we could also use the law of cosines to find either B or C. So we could go ahead and do both of those. Why not? So let's go ahead and make note that we're going to use the law of sines, or we can use the law of cosines, and that is our alternate version. Okay? And you'll see that you could use either. Okay. So now what we know is that sine of angle B, right here, sine of angle B, divided by side B is equal to the sine of 38, which was given. So here's 38, which you could see now we will divide by A, which is 13.6464. I'm going to use a few extra decimals. Then we'll multiply both sides by 19. And then we now know that B is equal to the sine inverse of this right here. I was going to try to copy that. I guess I could just write it out. Okay, so the sine inverse of this, see if I can move that down just a touch. And when we have the sine inverse of that, we see that B is approximately equal to 59 degrees. Now, let's try this with the law of cosines. So, looking for that angle B, we have the cosine of B, and now all we need are side lengths, this alternate version. So we need A squared plus C squared minus B squared all over 2AC. And you can see that pattern here. Here's B and here's B. So we have side B, we have sides A and C, but we're looking for the angle B. So we see that we have the cosine of B is equal to 13.6464 squared plus 22 squared minus 19 squared. And that's all divided by 2 times 13.6464 multiplied by 22. Okay, so now we have that B is equal to the cosine inverse of all of this. Let me redo that. And we'll just put parentheses around that. And B is about equal to 59 degrees. So that is the same value, same angle we got using the law of sines. Okay, so now to find the last angle, we have easy work to do because we know that angle C is going to be 180 degrees minus 38 degrees, and now minus this 59 degrees, and we will have 83 degrees. So we worked through that step by step, and now let's look at solving a triangle using the law of cosines, side, side, side. Now, if you are solving an oblique triangle using side, 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 we will use the alternative, so that alternate formula for the law of cosines, and we're going to find the largest angle of the triangle. So that's going to be opposite. Keep in mind, that's opposite the longest side. Now we'll find either of the remaining two angles using either the law of sines or the law of cosines. Now, the remaining two angles will be acute, okay? For the law of sines, you must use a rounded value. In the law of cosines, you'll use the given values rather than, for the law of cosines, use the given values, okay? And then we'll simply find the measure of the third angle by using that the sum of all angles equals 180 degrees. So let's look at this example here. Solve the triangle, and as you can see, we have side, side, side. Let me write that right below this. We have side, side, side. So now, step one, we're going to find angle C. And why are we starting there? Angle C is opposite the largest side, or you could say longest side. Probably would be better to say longest. Okay, so let's go ahead and do that. So we're looking for angle C. So we're going to have cosine of C equals, now we're going to use the other two sides. So we will have 10 squared plus 8.7 squared, and we'll subtract that longest side, 12.3 squared, all divided by 2 times 10 times 8.7. Okay, and so now we know that C is equal to the cosine inverse of this expression. And so we will have C is approximately equal to 81.9389 degrees. So C we'll just use 81.9. Okay, now we're going to find angle A or B using the law of cosines or sines, law of sines. So why don't we go ahead and do both again? Again, you do not have to do both, but let's just use the law of sines. Then we have the law of cosines. Of course, that will be our alternate version. And now let's go ahead and begin. So what we have is we're looking for angle B. So we're going to be looking for angle B. So the sine of B divided by 8.7 which is side B, equals the sine of 81.9389 divided by 12.3. So we have the sine of B equals 8.7 multiplied by and now we have B is equal to the sine inverse of this expression. Well, it's just not wanting to work right here. I'm going to try one more time. I'll just write it out. And we get that B is approximately equal to 44.5 degrees. Okay, let's see if we can come up with the same angle B using the law of cosines. Okay, so we have that the cosine of B, and remember, this is when we have all the sides. And we'll have 10 squared plus 12.3 squared. And we have minus 8.7 squared. Jumping the gun a little bit. And then that's divided by 2 times 10 times 12.3. So we have that B is equal to the cosine inverse. Let's give this one more try. If not, I'm going to have to find out what's wrong with my program. There we go. And so we have that B is approximately equal to, again, 44.5 degrees. So as you can see, we have the same angle. So either way that you're comfortable with. And so now we know that angle A is going to be 180 degrees minus 81.9 and now minus angle B, which is 44.5, and we come up with 53.6 degrees. Okay, so let's try an application problem. These are always a great way to practice these laws. So we have two planes that leave the same airport, okay? And the first plane leaves at 3 o'clock and averages 450 miles an hour at a bearing of south 70 degrees east. Now, the second plane, let's say 450, and the second plane leaves at 5 p.m. and averages 510 miles an hour, and this plane has a bearing of north 10 degrees west. How far apart are the planes at 6 p.m.? Okay, so now let's write a few things down. I think we could make a quick graph and just show what this situation looks like. And we have plane, we could call the first plane plane A, and we could show that we have south 70 degrees east. And we can go ahead and if we're 70 degrees east of south, then we would have 20 degrees here. Of course, this is 70, okay? And this plane is traveling at, and the other plane travels north 10 degrees west. So west of north 10 degrees. So now what do you notice? This angle here would be 90 plus 10 plus 20. So that would be 120 degrees. So now we can go ahead and place our dashed line in right here, and let's call that side C. And we're going to talk about side A and side B. So we're going to begin with the first plane. And the first plane travels from 3 p.m. to 6 p.m. And so that's for 3 hours. So we have 450 miles in 1 hour multiplied by 3 hours. And that comes up with 1,350 miles. And that is how far the first plane travels. I'll go ahead and just call that B. So we'll call this 1,350 here. Actually, let me write that. Side, we'll call it B equals 1,350. Okay, let's talk about the second plane. And that second plane travels from 5 p.m. to 6 p.m. and that's 1 hour. And so you can see that this is going to be the shorter side. And so we have 510 miles in 1 hour multiplied by 1 hour. And we have 510 miles. So now we have that A is equal to 510. So as you can see, we have side, angle, side. And now we can go ahead and use our law of cosines. So we can say that side C, which is going to be how far apart are the planes at 6 p.m. That's going to be C is equal to A squared plus B squared minus 2AB cosine of angle C, which is what we have. So we have 510 squared plus 1,350 squared minus 2 multiplied by 510 multiplied by 1,350. And here we have the cosine of 120 degrees. And if you put all of that in your calculator, whoops, C squared is going to be equal to 2,771,100. So if you take the square root of that distance, we'll have approximately 1,665 miles. And that's how far apart the planes are at 6 p.m. Okay, let's look at number 4. The distance between Miami, Florida, and New York City is 1,093 miles. The distance from New York City to Nashville, Tennessee is 759 miles. And the distance from Nashville to Miami is 816 miles. What is the measure of each angle between the towns? So as you can see, we have three sides. We have side, side, side. Let's go ahead and label this chart. So A, B, and C. This was not the best color to choose. So let's see if I can choose a better one. A, yes, that's better. B, and C. So we will have angle A, angle B, and angle C. And of course, you can see Miami is here. And of course, you can see that New York City is here, where angle B is, or vertice B. And of course, you can see that Nashville is A. Okay, and that'll help us over here. So we know that the distance between Florida and New York City is 1093. So we know that A is 1093 miles. They said that from New York City to Nashville is 759. So let's go ahead and put 759 there. And then Nashville to Miami would be B, and that's equal to 816 miles. Okay, so now if we're looking for all of the angles, remember that we are going to find the angle across from the longest side first. So that would be the cosine of A. And the cosine of A is equal to 816 squared plus 759 squared minus 1093 squared, all divided by 2 times 816 multiplied by 759. Now, we know now that A is equal to the cosine inverse, and let's see if we can duplicate this. Cosine inverse of this expression, and we see that A is approximately equal to 87.8122 degrees. Therefore, A is approximately 87.8 degrees. Okay, so now let's find angle B. So we see that angle B is equal to, and what we could try, let's try this. Couldn't we say that B is equal to the cosine inverse and then use our law? 1093 squared plus 759 squared minus 816 squared, all divided by 2 times 816 multiplied by 759. This should be 1093. There we go. And so now if you put that in your calculator, you will actually come up with B equal to 48.2472. So B is approximately 48.2 degrees. Okay, so now we just put that together and we can say that angle C is equal to 180 degrees minus 87.8 degrees minus 48.2 degrees. So C is equal to 44 degrees. Now, keep in mind that rounding will give, let me make a note here, note, rounding may give slightly different answers. So keep in mind about that. Okay, now let's take a look at Heron's formula for the area of a triangle. So given a triangle, and of course we have side, side, side here. We really shouldn't write that like that, but we have all three sides known. All three sides are known. What we can do now is use this formula. So we have that the area is equal to the semi-perimeter multiplied by the semi-perimeter subtracted by each side length and then taken the square root. Of course, we will need to know this semi-perimeter is 1/2 of the sum of all three sides. So what if we took a look at the area of the triangle in number 4 where we had the 3 cities? So we would have the side is equal to 1/2, the semi-perimeter we'll find that first. And that's equal to 1/2 multiplied by those 3 sides, those 3 distances between those cities that we were given. And we would come up with 13, I'll put it over here, 1334. So that is the semi-perimeter. So now what we will do is we will find the area. So the area is equal to the square root, and remember we need to use that semi-perimeter first. So that's 1334. Now we're going to subtract each side from 1334. So we'll have 1334 minus 1093, 1334 minus 816, and 1334 minus 759. So if you put all that in your calculator, you should get approximately 309, write that a little neater, 309,446 square miles. And that concludes this section.